In this video, we are going to implement a many-to-many relationship in a Spring Data JPA Kotlin project. I am using a starter source code in order to keep this video short. You can download both the starter code and the final project in the video description below. If there are things you don't understand in the starter project or you are new to Spring Data JPA, I recommend watching my introduction video that will show up as a card at the top. If it doesn't, the name of that video is Spring Boot Kotlin 4 Database Access using Spring Data JPA. Now we are going to take a look at the starter project. You will need to have installed IntelliJ IDEA Community Edition and MySQL on your local machine if you want to follow along. So if we open this file in the project repos, KT, repo stands for repositories. Here we have two entities, one called student that simply has an ID and a name, and the other one is course, also an ID and a name. And we will add the many-to-many relationship between student and courses. So a student can be enrolled in multiple courses, and a course can have multiple students enrolled in it. Also in this file, we have a student repository, which doesn't have any custom operation, and a course repository, and also objects that will be returned as REST API responses. We have controllers for both the students and the courses, and both of these controllers have one method, which is the find all. It returns all the objects in our system. Also the same thing for courses. The path for these endpoints is courses and students, so just a basic CRUD controller. And now if we look in the application properties, we see that this our project will access localhost 3306, which is the default MySQL port. We are using the MySQL driver, and it will access this M2M. It stands for many-to-many database that we'll need to create. It's going to use the root username for accessing MySQL and database password that will be read from an environment variable. And yeah, first we need to connect to our local MySQL using root, and we are going to create this M2M database. So create database M2M, connect to this database M2M, and we'll see that it's empty right now. Now we are going to create a running configuration. So we go to boot M2M application, and we are going to modify this running configuration, and we need to add the environment variable for database password. So db password, and in my case is empty, but if you have a password, then you need to fill it in that field. We apply. So now we have this running configuration, and if we start our project, it will run the liquid-based migrations, and the liquid-based migration is in this file right here. We basically have only one change set that will create the table for students. Again, the two fields, ID integer and name of varchar 255, and then it also inserts 3 rows in the student table, 3 students, Alice, Bob, and Charlie. And then we also have we are also creating the table for course, again with ID and name, and it adds 2 courses, math and biology. So now we are just going to run the project, and this migration will be executed when the project starts. Okay, we see that it started. So now if we do show tables, and we see that we have the database change logs and change log from Liquidbase and the 2 tables that we just created. And if we do select star from student, we'll see the 3 students that were added from course, again, math and biology. And also our REST endpoints, we have localhost 8080 students. So we see Alice, Bob, and Charlie, the 3 students. And in course, we see the 2 courses that we just added. Next, we are going to add the many-to-many relationship in our Kotlin code. So if we open repos.kt, we'll need to add it in both student and course. So in here, we will add it as a field called enrolled in. And the type of this field will be list of course. And we need to give it a default value, let's say list of. So in a previous Spring Data version, there was a problem between Kotlin data classes and JPA. And when we were doing many-to-many, we needed to do this as a var, as a var, a variable, and instead of immutable list, we had to use mutable list, and here also a mutable list of, which will create an empty mutable list. I'm not sure exactly what was the issue. Probably the way that Kotlin was compiled to bytecode or something like that. But it looks like in the most recent version, we don't need to do this anymore. So here we can use immutable list. So list, but keep this in mind. If you run into any issue, switch your many-to-many fields to mutable and to variables. So in here, there's an annotation for specifying many-to-many fields. The name is many-to-many. And the way that this annotation works is that we will need to use a join table. So we will create a table later with 2 columns. The first one is the student ID, and the second one is course ID, in order to tell JPA which student is enrolled in which course or courses. So in here, we will use join table, and we need to specify the name of the table. So the name of the table will be student enrolled in, and then join columns array of. So this will what join columns would do is it tells JPA which column it will use to go from student to course. So in here it will be join column, and the name will be student ID. We will create this table later. And also the inverse of this relation. So this will tell JPA how to find out for a given course which students are enrolled in. So in here it will be join column of course ID. Okay, so this looks good. And also on the other side of this relationship, on the course, we will have a field called students enrolled in, like this, and it will be again a list of student and list of, and again the many-to-many annotation. But now we don't need to specify the join table anymore. We can just tell JPA that this field belongs to a many-to-many relationship that was already defined in the student entity by this field enrolled in. So here we will use the mapped by field, and we need to specify the name of the field inside the student entity, which is enrolled in. Now we need to create this join table in our database using liquid-based migration. So we will go to liquidbase.xml in resources, and here at the bottom we need to create a new change set. So change set ID2 Vlad, and then here we do a create table. let's see, the table name was student enrolled in, and it had two columns, student ID and course ID. So student enrolled in, good. Student ID, type, I think it is a, yeah, integer, like that. We can add a constraint nullable false, just like that. And the other column is course ID. I think it's student enrolled in course, actually. Student enrolled in, yeah, we need to change this to course. Course. And this other one would be course ID. And then we also need to add foreign key constraints, add foreign key constraints. So this will prevent us from inserting incorrect values for student ID and course ID. For example, we have 3 students, 1, 2, and 3, and we shouldn't be able to insert a row in this join table for student ID 5 because that student doesn't exist. Okay, so in here, constraint name, let's do foreign key student ID. Base table name would be this table. Column name will be student ID. And this should be a reference to the table student and the field ID. And we need to do the same thing for foreign key course ID. So course ID will need to reference the field ID inside the table course. And also we need to add a unique constraint now. Add unique constraint inside this table. The unique constraint would be in student ID, course ID. So this will prevent for a student to be enrolled twice in the same course. So to have duplicate rows in our table, this wouldn't make too much sense. And also another nice side effect of unique constraint is that MySQL will create a secondary index based on student ID. So whenever we try to find which courses are associated to student ID, that operation will be very inefficient. Will be very efficient if we have this unique constraint. Without a secondary index or a unique constraint, MySQL will have to scan the entire table to find the courses IDs associated with the student ID. We also need to add a secondary index for the course ID, and this will make lookups of the students associated with the course efficient. If we don't add the secondary index, then every time we try to find the students associated with the course, MySQL will have to scan the entire table. So we add create index in here, table name, like that. We need to add a name to this index. Let's call it IDX course ID, and the name would be course ID, just like that. And also let's insert some values to our join table just for testing purposes. So insert in this table column name, student ID, value, let's say 1. And also, so it will be Alice is enrolled in math, course ID, also 1. In here, this one needs to be closed. Okay, let's restart our project, make sure the migrations work. Okay, it looked like they worked. So now if we do show tables in here and select star from student enrolled in course, yeah, we'll see that everything was created correctly. Now we are going to verify that JPA maps correctly to the database. So inside our repos.kt file, we will we will verify on API that these entities are coming through. So inside of a view student, we will add a new field which will be courses enrolled in, and this will be an iterable of string. And in case you're wondering, we cannot use the entity for courses in here. We cannot use view course inside of view student, because then if we add, we will also need to add view student inside of view course, and that would be a circular dependency, which is not allowed. So we'll just use the string. We won't see the IDs of the courses, but that is fine. And in here we also need to map the enrolled in map, and we'll fill in the name of the courses inside of courses enrolled in. And we'll do the same thing for courses. It will be students enrolled, and it will be an, again, iterable of string. And in here, in the toView function, we also need to map the students enrolled in map, just like that. So now if we rebuild our project, it should pick up these changes. So now if we go to our API and check out the students endpoint, we will see that Alice is enrolled in math. The other students are not enrolled. And if we call the courses endpoint, we will see that math has Alice enrolled already. Next, we are going to add a write operation to our API that can enroll students into courses. So if we go to our students controller, there will be a post operation in here, post mapping, and this will be on the path of the student ID, and the path name will be ID/enroll, and in here let's call this function enroll. So we have the path variable of ID, which is a long, and we also need to get this object that contains the course ID that we try to add the student to. So for now, let's just leave it like this and create this data class. So data class enroll in course, and here there will be course ID, which is long. So in here now we can add this request body argument to our function, enroll in, and yeah, that was good, enroll in course, this one, and we will return a view student, which will reflect the modified student. So first we need to make sure that we receive the good IDs for the student ID and for the course ID. So we will look up in the student repository, find by ID, and if we didn't find any student with that ID, we need to find an HTTP 404 not found operation. So we throw response status exception of HTTP status not found, and we need to do the same with the course ID. So course, and we need to wire the course repository to our controller. Course repository. So we need to look it up in course repository, find by ID, and this one will be in enroll in dot course ID. Again, the same thing. if we don't find it, we need to throw an HTTP 404 to the API. So now we need to modify the student. So we need to make a copy of the student, copy, and append the new course to the list of courses. So enrolled in equals student.enrolled in, I think it's, yeah, plus the new course. So now we need to save this new copied object to our student repository .save, like that, and also convert it to view, and this is what we return from our method. And now if we rebuild this, okay, now it should be good. And we are going to create a new operation in here. This one will be post. So again, localhost 8080 students, let's say student 1 enroll, and inside the body will be it will be raw text with JSON. So we'll do course ID equals 2. So we will enroll Alice in biology as well. So we see that now Alice is enrolled in both math and biology. And if we go here, we see Alice is enrolled in biology, and when we get the list of all students, we see that it's correct again. Now let's enroll also Bob to biology, just like that. And we want to make sure that the courses can have multiple students enroll. I'm just double checking that. And also we can double check something like an invalid student ID. Yeah, we see that we get HTTP 404 not found, status 404. Or if we do this one with course ID 3, we should get the same thing. Yeah. This is the end of the video. The source code can be downloaded from the video description, both the starter code and the final code. If you want to support the channel, please consider subscribing, liking the video. It helps a lot. Thanks for watching.